Welcome to this video. Let's talk about this question. It says that an automobile traveling along a straight line road uh, increases its speed from 29 feet per second to 42 feet per second and 180 feet. If the acceleration is constant, so how much time elapses when the auto moves the 180 feet distance? Okay, so let's write down what we are given. We are given the initial speed. The initial speed, let's call it V naught, is 29 feet per second, and then we have the final speed, let's call it V, which is 42 feet per second. Again, the displacement, or in this case the displacement and distance, is same because they are traveling along the same line. So this is 180 feet. That is also given to us. All right, let me just try to draw the straight line as well and represent that how the situation is. So let's say this is where they are starting, and this is the starting point where we have the V naught, and this is the end point where we have V, and this distance is 180 feet. All right, so we are given that if the acceleration is constant, so how much time elapses between this period. Before we can find the time, we need to get the acceleration, and if we need to get the acceleration, we got to use the third equation of motion, I suppose, because the third equation of motion says that V square is V naught square plus 2as. We have V, which is 42, so we have 42 square. We have V naught, which is 29 square, and then we have 2 times A, which is unknown, times the S, which is the displacement, which is 180. I'm gonna need the help of calculator over here. So I have one. I'm finding 42 square, which is 1764. Then I need 29 square, so 29 square is 841, and 841, and then I have 180 times 2, right? So 180 times 2 is 360, so that's 360A. All we got to do is a little bit of rearrangement of the equations. So here we have, let's try to subtract, I believe 861 both the sides. So if we do 861 subtraction of 861 both 841, pardon, both the sides. So I'm left with 923, and that is equal to 360A. And then I divide both sides with 360 to get the acceleration as 2.56. Or I can also write it as, A is equal to 2.56 meter per second square over here. So this is the value of acceleration. But we don't really need the acceleration, we need the time. And now we can easily use the first equation of motion and get the value of time. We know that the first equation of motion is V is equal to V naught plus AT. So V is, we already know it's 42, right? It's 42 feet per second. V naught is 29, so we have 29 over here. Acceleration we just found, it's 2.56, and the time is something which we need. Let's subtract 29 both the sides. So we have 42 minus 29, which is 13. So we have 13 over here, and this is already 2.56t. So if we divide both sides with 2.56, I'm getting the value as, over on the left, I'm getting 5.08 up to 2 decimal places, and this is nothing but the time. So finally, the time to increase the speed from 29 feet per second to 42 feet per second while covering a distance of 180 feet is 5.08 seconds, which is the final answer. I hope you enjoyed this video, and I hope this question makes sense to you. Thank you very much.